Hello guys, in this video I would like to discuss focusing on the topic of metals and non-metals. So here you can see the periodic table actually, and the pink part is actually what we call as metal, and the green part is they are the non-metals. So metals, they are usually focus on, we would like to focus on specific main groups. So here we have like some groupings in the periodic table. The vertical grouping, this thing is called group. So for example, here we have what is called group 1, group 2, and here we have group 3, group 4, 5, 6, 7, and this part is group 8 actually, group 8 or noble gas. And for the horizontal grouping is what we actually call period. Yeah, period 1, period 2, period 3, and so on. But let's focus on group now. So the vertical grouping, vertical category. The vertical category actually groups atoms with similar chemical characteristics. So yeah, if they are in the same column, then usually they have similar chemical characteristics. So metals, especially in group 1 and group 2, are kinda reactive. So they are very prone to reactions. But if we are speaking about metals, we should discuss actually the structure of a metal first. So imagine that you're zooming into metals. Yeah? So like let's say a bar of sodium, a bar of Na. Then inside this, there will be like a lot of sodium atoms, and there will be like a lot of smaller electrons. Yeah, electrons are actually subatomic particles. So you know that here, this atom, yeah. For the longest of time, people believe that atom is just like this. So the atom is just, the shape would be just like a billiard ball, yeah. But then people realized that atom is actually consisting of the nucleus, so the core of an atom, and this orbit where the electron is. Yeah, the electron is a particle that carries charge, subatomic particle. And inside the nucleus, yeah, there is like proton and neutron. We've learned this in previous grades. So metals, specifically, they would be like this. So they would be like a tiny regular arrangement of metal ions. So here metal atoms, very tiny, and then there are like a lot of electrons kinda filling the gaps between this metal. So that is why we call them delocalized electrons. Yeah, like out of place, or like we can call them offside. Yeah, they are surrounding the metal ions. So you know that electricity is like moving electrons, yeah, moving electrons. So because of this structure, metals are conductive, especially they are able to conduct electricity very nicely. Another property of metal is that they are malleable, or they can be reshaped. Yeah, they can be reshaped. Because you can see that here, actually metal, yeah, they form like layers, like the first layer, the second layer, the third layer, fourth layer, fifth layer, and so on. So imagine like you're pushing only this part, so you're giving like a very big push, or a very heavy punch. So the metal layer would just slide, so they would move a bit. So that is why metal would not just break, but they can be reshaped. So at most that the part here would just be like dented, yeah, dented, not broken. So it's the ability of metal to be malleable. And also metals are known to be ductile, meaning that they can actually be pulled to form like a thinner form factor. Yeah, imagine like you're making a cable from a copper, then the copper you pull, then you create like a thin long copper wire. So that's ductile. So not all atoms would have this ability. So imagine that you're pulling something, that they would just break apart. So the most appropriate definition of metal structure is that they're actually metal ions in the sea of the localized electron. Yeah, this is the main definition. So that's why they have the ability to conduct electricity. So the ability to be reshaped or to be malleable comes from the fact that they are in the form of layers. So the layers can just slide over each other. So this is the main property of metal. Usually metals are also shiny. So they are also shiny. Well, non-metals, if you need to know, then non-metals are not shiny, so they're kind of dull, and they're not malleable, they are not ductile as well. Usually non-metals are also a very poor conductor of both heat and electricity. So it's exactly the opposite of metals. Yeah, but here we would like to focus our attention to metals. Now metals have different reactivity or activity series. So this graph, yeah, some school would require you to actually memorize this. But yeah, for the real exams, typically official exams, you kind of have to know this. There are a lot of ways to memorize here. Please refer to some other interesting songs or ways to memorize. But here we see that descending order of reactivity series of metal. So here we have potassium, so one of the most reactive metals, sodium, barium, calcium, and so on. So down we have platinum as the least reactive metal here in this list. So the hydrogen is not a metal here, but it serves as like a baseline. Yeah, it's just like a baseline. So at the moment you can kind of ignore it. So it's okay. So this part, so I think like until barium or even, yeah, this part, they can react with water easily. Yeah, they can react quite violently. No, I think until sodium. Yeah, it's this part. So they can react with water. So for this part, they can react with water, but you need like really hot water, so like steam. So you see that even with the same thing with water, reaction with water, then they would have different reactivity. For potassium or sodium, even if you put like just a tiny bit of them inside water, then they would explode or like creating an explosion of flammable stuffs that you can observe. But for barium, even if you put them in cold water, then they would very slowly react. Only if you put them inside hot water, then the reaction will be accelerated and they can actually react. For tin, lead, then copper, mercury, silver, gold, platinum, then even if you dip them inside water, then there will be no reaction. Yeah. So these things, yeah, very violent to water. So if you must know the position of this, yeah, the metals, yeah, especially group 1. So group 1 is more reactive than group 2. So this part here is very reactive to water, while on the right side of periodic table, yeah, the reactivity actually goes kind of down for metals. Okay, for reaction with acid, so all of these things can react with acid until this part. So this part can react with acid. This reaction with acids. Yeah. But below hydrogen, they cannot react with acid. They cannot react with acid. Yeah, that is why now you see that people often save their money as gold, because gold is not reactive and gold cannot be corroded, cannot be reacted with acid. Even if it is wet, then that's still fine. You still have the same mass, even if you store them for tens or 20 of years or whatsoever. So reactivity of metals would actually affect their reaction as well to their surroundings. So in this case, there is a phenomenon where the metals would react with air and water to form what is called as rust. So here, in order for a metal to be rusted, air and water must both be present. So if only one of them is present, then you cannot actually rust a metal, so must be put. So on the second example here, we put a thin layer of oil that prevents the air to actually get exposing the parts of the metal. So that is why here in this part, the second file, it's not rusting. And here on the third file is only air, so even without water, so it will also not rust. So rust would actually appear on metals that is exposed to both air and water at the same time. So of course, rust is a very dangerous process, and sometimes we don't want it. Like it's kind of important for us to be able to prevent rusting, because you know that, imagine like you're boarding a ship and you see that some part of the ship is rusty, then you would actually worry about your own safety, because the structure would be kind of weaker compared to a whole ship that is not rusted and well maintained. So there are some ways for us to actually prevent rusting. So the first way is what is called by barrier method. Barrier method. So we just coat our metal with paints, with oils. Yeah, if we put paints on top of the metal, then actually the paints would prevent air or water to infiltrate to the metal part, so it's not as easy to be exposed to air and water. Then another way to actually prevent rusting is also what we call by sacrificial protection. Sacrificial protection. So here, for example, we see a ship hull. Yeah, a ship hull usually is made from steel. Steel is an alloy actually. Yeah, it's a mix between multiple different metal atoms. But here, yeah, let's imagine that this is iron. Yeah, iron. And we see that iron is kind of reactive. Yeah, iron here is kind of reactive. So if we want to protect the iron from rusting, we coat the ship and we put something that is more reactive, which is zinc. So if you see from the reactivity series, zinc is above iron, meaning that zinc is more reactive compared to iron. So if we put zinc on top of iron, then the water would actually find the way to react with zinc first, because zinc is actually more reactive, right? So now your iron, the main structure of the ship, would be relatively safe, because the zinc is sacrificing itself so that the iron structure would be safe. So that is why it's called sacrificial protection. So we put something that is more reactive. If you put something that is less reactive than iron, yeah, it's a bad idea, because now the water will try to find a way to infiltrate the iron first. So the iron will be the first one to rust actually. So that's a bad idea. So the idea of sacrificial protection, actually, you put something more reactive on top of the iron. So last part about reactivity series, there is one interesting thing as well. You do know that batteries, yeah, like some of the ancient batteries are created using like this strip of metals. Yeah, sometimes you will also see this strip of metals. And the potential, yeah, the voltage of a battery would rely on the difference of reactivity. So like the more difference in the reactivity, the higher the voltage that they would produce. So here, for example, copper and magnesium. Yeah, copper and magnesium, let's see their difference. Copper is here, kind of low, and magnesium is here. So the difference is this big. So they would create like a quite potent battery. But imagine like I put here sodium compared to silver. Yeah. Oh, this would be an even more potent battery. But then of course, yeah, just having like theoretically having like a bigger voltage does not mean that it's economically feasible, because producing silver batteries to everyone in the world would be so expensive. So that's why people, yeah, would just, oh, okay, sodium is okay, but let's use copper or something else. Yeah, but the main idea, the main concept is that the bigger the difference in reactivity, the bigger also the voltage that will be produced in the battery. Okay, so I guess this is about metals and non-metals. Yeah, I think the properties of non-metals are quite the opposite of metals. So just knowing and understanding the properties of metal, especially this part, so they are shiny, malleable, and ductile. The non-metals are dull, cannot be reshaped, and not ductile. And please remember that the categorization, so the groupings, so the first and the second group usually, yeah, they are metals. And then here in the middle part, it's actually called the transition metals. Yeah, because they are like the bridge before the metals here, the metals group 1, 2, and the non-metals group 3, 4, 5, 6, 7, and so on. Yeah, so the transition metals are in between in the periodic, so that is periodic table, that is why they are called the transition metals. So they kind of have like similar properties to group 1 and group 2 metals. Yeah, but the other thing is that they are colorful and they are more dense. Yeah, more dense, better heat and electricity conductor actually. So this is about these materials. In-depth explanation about metals, alloys, non-metals, and the other things can be discussed in other video. Hope this helps. Thank you.